My name is Benjamin Wachter, and this is Lab 4 for Physics 2212. In this lab, we discussed many fundamental relationships and properties of circuits, including currents, and the relationships described in Ohm's law, as well as the node rule and loop rule, which describe the conservation of energy and charge within a circuit. We also explored relationships in circuits, including the electric potential and capacitance and resistance in closed circuits. The first part of the experiment asked to set up a simple circuit with two series resistors. The predicted current from the two resistors in series was 0.02 amps. This is what was observed when this simulation was run. The second part asked to reconnect the wire to connect the opposite direction to the ammeter. It read the same value when the wires were connected oppositely. When replaced with a voltmeter, the second ammeter read 0, and the voltmeter read 3 volts, which was the potential difference between the two ends of a now open circuit, and the ammeter read 0 because the circuit was now open and carried no current. After reconnecting the circuit and having one ammeter in place, the potential difference was found between the various points as follows. The current, was still 0.02 amps. Theoretically, because of the loop rule, the total potential difference should have added up to 0, which was in fact observed in the simulation. The graph in the upper right-hand corner of the screen shows the potential difference measured from the negative battery terminal to various points around the circuit. When the voltmeter was used to measure the potential difference across the 100 ohm resistor, the ammeter reading doesn't change because the voltmeter does not significantly alter the current in the circuit, as the current running from end to end of the voltmeter is not significant. When the voltmeter was used to measure the potential difference across the 100 ohm resistor, the ammeter read 0.02 amps. When a parallel ammeter ran across the 100 ohm resistor, both ammeters read 0.07 amps. This is because the parallel ammeter conducted current, so the current at point F is split. And because of the loop rule, the new combined resistance of the parallel circuit must also equal negative 2.041 volts. Using the predicted model in PhET, the following values were calculated. The resistance of the 47 ohm resistor was 47.95 ohms. The resistance of the 100 ohm resistor was 102.05 ohms. The resistance of the wire was 0 ohms, and the resistance of the ammeter was 0 ohms. Moving on to the RC circuit. When the capacitor, the battery, and the resistor or light bulb were all connected, the light immediately lit up and began to dim as the capacitor charged. Once the capacitor was charged and the battery was disconnected, the capacitor began to discharge. The light immediately brightened and then began to dim again. As the capacitor charges, the current decreases, and as the capacitor discharges, the current is initially what it was when the circuit was first connected, but decreases as time goes on. The time it took to charge the capacitor at 10 ohms resistance was 3.15 seconds. With 20 ohms of resistance, it was 6.21 seconds. The time it took to discharge the capacitor with 10 ohms of resistance was 7.8 seconds. And the time it took to discharge the capacitor with 20 ohms of resistance was 15.57 seconds. When the natural log of potential difference over the potential difference at time equals 0 was plotted, as time approached infinity, the value of the graph approached 6. This is consistent with RC, which equal to 30 ohms times 0.2 farads, which is 6. Had I instead used a real-life ammeter, the current recorded would be less than the values given by the PhET simulation. This is because actual ammeters and wires have greater than 0 resistance, so the value of R for the circuit would be greater than what was used, and because delta V equals IR, I would be lower. The simulation predicts that the capacitor would instantly become fully charged with no resistors. In real life, while the capacitor would charge very quickly, the resistance in the connecting wire would delay the charging from happening instantaneously.